Hello students, so now let us start the third part and the final part of this first chapter of Social Science Class 6 NCERT book, Locating Places on the Earth. Today we will talk about various time zones. Now before I proceed, let me briefly talk about what I have covered in the last class. Okay, so we have talked about the parallels of latitude, right, which are basically horizontal lines that circle the earth parallel to the equator. See over here, this parallel lines, this is the 0 degree parallel line, this is the 10 degree, this is the 20 degree, 30 degree, 40 degree. Similarly, we have also considered the meridians of longitude, which are basically vertical lines that run from the North Pole to South Pole. See here, this is the 10 degree meridian, another 20 degree, 30 degree. Now here we have on the both sides of the 0 degree, which is the prime meridian, on the east side as well as on the west side. So here also 20 degree, 30 degree. Okay, so basically the difference is the same, 10 degree, here 20 again 10 degree, and so on and so forth. Okay, now here in this small picture you can see the various meanings. So you can even make this globe by yourself. So basically this is regarding the latitude. So equal angle, here I have shown you the case for angular. This is the protector. So you see, this is the angle of 15 degree, this is the angle of 30 degree, and so on. So this way you can make the latitudes on a sphere or globe. Similarly, you can also make the longitudes like this. For that you have to cut. Here also, as you can see, we have cut the globe in two equal halves. Similarly, in the vertical direction, if we cut, then we can make our longitudes as well. From here, say 0 degree, again 15 degree, here 30 degree, and so on the east side, and this is on the west side. See, this is how we can make them. Fine. Now together, the latitude and the longitude are the two coordinates of a place. So this was our basic aim of studying how to determine the location of a place. So we are using the concept of latitude and longitude. So in this way you can say that indeed Delhi lies at 29 degree north latitude and 77 degree east longitude. This we have again discussed in our last class. Okay, so again you can see the various. So if this is the globe, then these are the very important two lines. This is the equator, see, which divides into northern hemisphere and southern hemisphere, and this is your 0 degree Greenwich meridian, which divides in the western hemisphere and in the eastern hemisphere. Okay, now after this, let us see a small video on the globe. So this is the actual globe. I am showing it to you. Now this is our country India over here, and this line is your equator, which is the 0 degree, which has 0 degree latitude. You can also see other parallel lines, say for example here and here as well, here as well, say for example here as well, all the other parallel lines. Now you see all parallel circles which are parallel to the equator. These parallel circles run from equator to the various poles, say the North Pole. These parallel circles, they are known as parallels of latitude. Now here you can see 0 degree latitude, 10 degree, 20 degree. Okay, so let me again show it to you. So this is basically the 0 degree latitude, which is the equator, right? Then this one is the 10 degree, this one is 20 degree, this one is 30 degree. So they are basically circles parallel to the equator. Okay, again another circle. They are together all known as parallels of latitude. See, another one over here, and so on and so forth. Okay, this is 30 degree, this is 40 degree, next 50, 60, 70, and this one is 80 degree latitude. Okay, so you can see. Similarly, you can also see the longitude lines as well. See here, one longitude, another longitude here. Okay, so you can see them all on the globe. Now you can also see how the various longitudes, see from here, they are emanating from the North Pole over here. Okay, so let me again draw. So as you can see, so these are the longitudes. They are all emanating in this way from the North Pole. See over here, another one. Okay, and we also have the latitudes as well. So in this way we are getting the grid system. Fine, which is basically the mesh of the latitudes and the longitudes together, the various longitudes. And here you can also see the parallels of latitude. This one, see, this one, yes, another parallels of latitude. Okay, so you see, this is how the globe looks like, and we are here in India. Now let us try to draw the latitudes and longitudes on this sweet lemon over here. Suppose this is the North Pole over here. Fine. Suppose this is the North Pole, then and this one is the South Pole. So let me draw first the various longitude. Suppose 0 degree longitude over here. Next, let me draw the 180 degree one. So this is the 180 degree one. Next, similarly, I can draw other longitudes from here to here, right? You can see. Okay, so let me again draw them. So like this. So these are the previous ones. So first I am drawing the longitudes on the sweet lemon. See, basically this is how you can draw. I was trying to draw this. Next, let me draw the latitudes. So for that I have to first draw the 0 degree equator at the middle, then draw the various parallels. You can draw 10 degree or even 15 degree depending on the angle. So these are the parallels of latitude. Okay, so in this way you can draw your grid system on the sweet lemon. So this is our basically grid system on sweet lemon. Grid system on sweet lemon, and here you can see the actual globe. Fine. Okay, so now let me show you yet another very interesting thing. See this picture here, as if we can cut the globe. I am showing you the inner structure. Okay, so as I was showing you previously, so this is the 0 degree prime meridian. Okay, see over here, this is the 0 degree. Now from here, at every 10 degree angles, we can draw the various longitudes, right? So here you see, this is the on the east side of this 0 degree prime meridian, right? So you see, this is your 30 degree east longitude. Now interestingly, here is Cairo city, here is Harare, and here is Durban. They are all lying on this 30 degree east longitude. I am just showing you this thing, interesting fact. Another thing, here you see New Orleans and Cairo here, they are all falling on what? You see 30 degree north, this is latitude. So they are all following on this parallel 30 degree north latitude, like this. So I have shown you the parallels of latitude, and here also I have shown you the longitude as well. Fine. Okay, now let me again discuss a very important concept, the distance between. So distance between the latitudes and longitudes. So this is a very important concept. So first let me tell you that, as I have been telling you, the parallels and the meridians on the globe form a net, which is also known as graticule or your grid system of Earth. Remember, these are all imaginary lines, all imaginary, though they don't exist. We are doing this for the sake of finding locations and all that. Now let's start with the longitudes over here. Fine. Now you see, there are overall 360 meridians. Say if this is your prime meridian 0 degree, then at each angle you can draw a meridian, right? So overall 360 meridians at a gap of 1 degree. So in a way we have got 179 east meridians and 179 west meridians, where we have excluded the 0 degree prime meridian and the 180 degree meridian. Another very interesting thing you observe is this. See the distance between these meridians. Here, say for example, just a second, where is it? Yeah, here see the distance is much larger compared to here. The distance is much smaller, and here the distance is the largest. So in a way you can say the distance is this between the various meridians, which are all following on a parallel. So we are moving around a parallel. If we do so, then we find the distance is the maximum at the equator, and this is your maximum. It is around 111 kilometers. This we have worked out as well. Next, this is the same. Remember, in our first video or probably second video, we have done this calculation. Check this. Next, at the Tropic of Cancer, the distance decreases to 102 kilometer, later on 44 kilometer, and at the poles all the lines meet. So this is basically zero, no distance between the meridians, because all of them emanate from there. Okay, fine. Now another very important thing is this. Well, we have used basically latitude and longitudes for determining the location of the Earth. Now the method is being used even in today's modern age quite effectively. Say for example, the Geographic Information System, or GIS in short, again Global Positioning System, GPS, they are as well as our Google Maps, Wikimapia and Bhuvan of ISRO on the internet, they make use of these latitudes and longitudes to determine the location of places on the earth. Okay. Now this technology is also available on mobile phones and motor cars. So here you can see the GPS enabled devices, two such examples. Fine. Now in this case, our India has also developed its own system, positioning system. This is known as your IRNSS, Indian Regional Navigation Satellite System. And so our country has achieved self-reliance in global positioning system with the help of IRNSS, locating any place in the Indian subcontinent. So this, in the world map, this is the coverage. This blue region you can see is basically the coverage of your IRNSS. So in this place, anywhere we can locate the location. So for this, India has launched several satellites, and maybe we will be launching more in the future as well. And after more satellites, our region will probably expand. So we will be slowly and gradually able to cover more and more of the region. Okay. Now, before I proceed forward, can you answer this question? Which of this is the correct one that shows you the correct latitude? See from here, the lines, they are equal distance, as if it is on a square, but we are working on a sphere. Remember, so we cannot have that. Look over here. Here, this is the north, this is the south, but the lines, they are not starting from the north-south, but to some other imaginary place along the equator. So again, this is not correct. Again, this here, this is quite similar to this one, but here the lines were different compared to here. See, again, since this is not starting from the north and south, which is over here, so this is not correct. So in a way, you can see this is the correct one. Now if I draw a globe like this and I draw like this over here, okay, but I draw the lines like this, then again it will be incorrect. Like this case over here, the lines has to be curved like this, because we are working on a sphere, not on a plane of paper. This is important, students. So only this one is correct. Keep this in mind. Next, in our last class, I have discussed about this various zones on earth: torrid zone, temperate zone and frigid zone. Remember, now I have discussed it quite briefly. Here I am going to tell you the actual reason why we basically do this demarcation. What is the actual reason? What is the logic behind such demarcation? You must be thinking. Now, see, the reason is as follows. Well, here you can see the sunlight coming from the sun on the earth. They are parallel light. See? Where is it? Yeah. They are all parallel rays coming from the sun. Now, these sun rays coming towards the earth travel in straight lines. However, as our earth is spherical in shape, these are not perpendicular to all parts of the earth's surface. See, they are not perpendicular. Where will they be perpendicular? They will be perpendicular if the surface is like this. But here you see the surface is curved. Okay. See, the surface is curved. So, although the light is the same, but it is falling on a much larger area. Compared to here, the area is much larger over here. Okay. Fine. So let me continue. As the earth is spherical in shape, these are not perpendicular to all parts of the earth's surface. In some parts they are perpendicular. You see, this part, it is perpendicular, but on the other parts here they are slanting. Now the perpendicular rays, they occupy less area here, and the part where the rays occupy less area, they will receive bright sunshine and greater heat. You see, the heat content is the same in each of them, but the heat is being distributed in larger area over this place where the sunlight is slanting. But here the heat content will be falling on a place which has smaller area. So what will happen? Here the surface will get heated more and the air becomes hotter. Whereas in the slanting area, this one, you see, the sunlight appears less bright because the same heat is being distributed over a large area, and so the surface there gets less heated and the air is also less hot. As a result, we have a distribution of temperature. So as if from here to here the temperature slowly decreases. This is what I told you in my last lecture. So this unequal distribution of the heat received from the sun results in decreasing temperature from the equator to the north and south poles. And based on the distribution of this temperature, the earth can be divided into torrid temperatures and frigid zones, or they are also sometimes called tropical, temperate and polar regions. Okay, so this was the actual basic idea behind the division of these regions. Fine. So now, after approximately 20 minutes of very important discussion on globes and latitude, longitude and various other stuff, we are finally ready to talk about the understanding time zones, which is our last part of this chapter. Now let's make the globe rotate again and again from west to east. So because this is how the earth rotates. So this is the imaginary line. So let us rotate it from the west to east like this. So things will rotate like this. Basically this is how our planet spins around this axis and making a full turn every 24 hours. This is approximate. The time is little bit different, but this is okay for our case. So this means a full turn, which is how much? 360 degree, right? This means 15 degree per hour. Why? Because 360 degree turn in 24 hours. So this means how much time in 1 hour? So 360 divided by 24, which comes out to be 15. So 15 degrees per hour rotation. Now let us mark the meridians of longitude every 15 degree. Here, say for example, if this is 0 degree, then this is 15 degree east, 30 degree east, 45 degree east, and so on and so forth. Let us mark them every 15 degree. Now moving eastward from the prime meridian, that is moving in this direction, what happens? We get 0 degree, 15 degree, again east. So east, 30 degree east, 45 degree east, and so on. And so on every 15 degree up to 180 degree. By doing so, basically we are adding 1 hour, plus 1 hour, plus 1 hour, plus 1 hour, and so on. So you see, if it is 12 am, then here we have got 12 plus 1, 1 pm. Here again 1 pm plus 1, 2 pm. Here also we have 2 pm plus 1, again 3 pm, and so on. So this is the same as I am telling you as adding 1 hour of local time with each meridian. So if it is 12 pm or noon at Greenwich, it is 1 pm local time at 15 degree east, 2 pm 30 degree east, and so on. But going westward, it is the other way around. So if we move in this direction, say let me use a different color, then here you see, if we move in this direction, then it is minus 1 hour. So if it is 12 am, then here it is minus 1, 11 am. Next on 30 degree west, we will have 11 a.m. minus 1 hour, which is your 10 a.m. and so on and so forth. So it will be 9 a.m. at 45 degree west. Okay, so this is how things work. This is basically how we are basically defining the time zones, taking into consideration the fact that we have 360 degree rotation every 24 hours. Now let us look at this textbook question. So two friends, one is sitting in Porbandar, Gujarat, and another in Tinsukia, Assam. So Gujarat, and so this is Porbandar and this is your Tinsukia. They are separated. Fine. How much is the separation? You see, approximately 30 degree is the separation. Now, this is the difference, of course, in the longitudes. Remember, now the friend who is sitting in Assam says that it is dark, whereas the friend sitting in your Gujarat, Porbandar, he says there is sunlight. Why? Because there is a difference of how much? Remember, how much? Every 15 degree we have 1 hour. So since the separation is around 30 degrees, so there is a gap of around 2 hours. So this means that while the sun has set over here, it is still sunrise. The sun is still on the sky. So in this way you can explain the difference between local time. Okay, by considering the longitude of your place. Now you see, all these standard times are organized. No, I will cover the part later on. So I was here. Fine. I was talking about the friend's situation sitting between Porbandar and your Tinsukia, Assam. Now with this you can imagine that if we have a country, then in each location we will have different longitude. So this means the local time will always be different between the longitude. So think of it, how much chaos it will create. So person sitting in Kolkata will say it is 5 p.m. now. Let us go to watch a movie or so, which is going to be released at 5 p.m. But the movie is being released in, say, Mumbai. He is going to watch online something, but the movie is being released in Mumbai's local time 5 p.m. which comes later on, right? So in this way the person goes to the watch through the TV or internet, and he has to wait because it is still not 5 p.m. in Mumbai. So you can understand how much chaos it will create. So this means we should try to avoid this chaos. So how do we do that? So basically what we can do is we have to decide on a very particular time for a country. That is, we have to adopt a sort of standard time for an entire country instead of considering local time for the various parts of the country. So in this case over here, instead of considering local times in all these places, we consider an overall standard time so that we can have a convenience in life. Okay, and this is based on one of the meridians passing through the country. Now in India we have the Indian Standard Time, which is 5 hours and 30 minutes, also 5.5 hours ahead of the Greenwich Mean Time. Now you might ask, how is this local time defined? So let me give you yet another important idea. So you see, this is India's expanse between 68 degree east and 97 degree east longitudes. Fine. So what we have done is the longitude which is at 82.5 degree east, this is over here, this one. We treat this as the standard meridian of our country. So the local time at this meridian is taken as the standard time for the whole country and not just a part of it. And this is known as your Indian Standard Time. So in this way we will not have trouble. Say for example, it will be difficult to prepare a timetable for trains which cross several longitudes in India. So a train traveling from this place to this place, if we have local times, then how are we going to prepare the timetable? Say for example, there will be a difference of about 1 hour and 45 minutes in the local times of Dwarka in Gujarat and Dibrugarh in Assam. And so if we use the standard time, then we can use an overall single timetable. So this is what I was telling previously. That is, we have to adopt a standard for whole of the India. So this is our Indian Standard Time, which is 5 hours 30 minutes ahead of the Greenwich Mean Time. Fine. Okay. Now all these various countries, they have their own standard times, right? Now these standard times are organized basically in time zones which broadly follow the 15 degree in the graph here, these time zones. So this is one time zone, this is another, this is another, this is another, you can say. So time zone centered around, see, the 15 degrees. So another time zone, and so on and so forth. Also we can see over here, you can see them. So this is 0 degree, this is your 0 degree time zone, this is your 1 hour time zone, 2 hours, so on and so forth, right? So our country is like this over here, this is +5 and so on. Also you see that the lines dividing the time zones are not fully straight. Why? Here, say for example, this is little bit tilted. Also here this is tilted. Why? This is so as to, you see, respect each country's standard time and therefore tend to follow the international border. The number written on some countries over here are the number of hours to be added to the GMT to get their standard time. So if it is positive, then they have to be added. If it is negative, it has to be subtracted. So say here for India it is 5.5 hours and so on. See here, yes. Whereas you see for this country it is -3. In America, this zone here we have -7. In particular this zone we have -9, and so on and so forth. Okay. Now yet another example. See, Kabir lives in a small town near Bhopal. He tells his friend Alok that they will not be able to sleep tonight. A day and night cricket match between India and England has started at 2 p.m. in London. This means that the match will begin at 7:30 p.m. in India and finish well in the night. How do you know? So the question is, do you know what is the time difference between India and England? Now, as we have seen over here, you see this is India and this is England over here. So it is on the east side of the Greenwich mean here. This is the Greenwich meridian, okay, and so we are on the east side, and so India is located east of Greenwich at 82.5 degree east longitude, and so the time difference is approximately 5 hours 30 minutes ahead of the GMT. Now how do you get this 5 hours 30 minutes? Basically this number comes from this 82.5 degree. So what you do is divide 82.5 degree by 15 degree, and because for every 15 degree we have 1 hour, so this is 82.5 degree on the east side. So if you do the division, you see the answer is 5.5. So this tells you it is 5 hours 30 minutes. Okay, fine. So this is how we explain that it will be 7:30 p.m. in India when it is 2 p.m. in London. Now this is also important to remember that some countries, they have got very great longitudinal extent, and so they have adopted more than one standard time. Say for example, over here you see in American continent, in this is USA, right? How many time zones are there? There are so many time zones, because if we use a single standard for this entire country, then we will have a lot of trouble over here. So we have got different time zones in this part. Okay, say for example in Russia there are as many as 11 time zones, right? Okay, so you have to understand that our earth has been divided into basically 24 time zones of 1 hour each, and each zone covers 15 degree of longitude. See for example, this is the number of time zones of each country. Say for example, this is United States of America. There are 11 time zones. The top of the list is your France. Number of time zones 13. Okay, you have to consider the various other regions where France has domination and all that to take into account of this. United Kingdom has number of time zones 9. Okay, Brazil has 4 time zones, and so on and so forth. Canada has 6 time zones. Fine. Okay, now finally, while the prime meridian was fixed at Greenwich, the opposite line, which is approximately 180 degree longitude, is known as international date line. Here you see, let me show you on the graph. Yes, this is your 180 degree. Yes, this one, you see, plus minus 12 plus 12, this is your IDL or international date line. IDL, international date line. Now, so if we cross it by ship or plane, we need to change the date on your watch. If you cross it traveling eastward, then you have to, so if we cross it eastward, then we have to subtract 1 day. Okay, say from Monday we have to go to Sunday, and if we have to traveling westward, then we have to add 1 day. Fine. And remember, it deviates at different places so as to avoid dividing some countries into 2 different days. Okay, so suppose in India in Assam it is Monday, and in Gujarat it is Sunday. Think of the consequences, how much trouble, not just your train timetable, not just your watching movie and all that, there will be so much chaos. Okay, so yet another, this is the ideal I am showing you. So basically imaginary line again, this is not real, which follows the 180 degree line of longitude, and it passes through the Pacific Ocean. Remember, it was established in 1884. This I have discussed in my last video. Okay, and ideal is not a straight line, so as to avoid dividing certain landmass into 2 parts. Okay, fine. So these are the important concepts which we have discussed in this chapter. Importance of maps to represent the area of the earth, whether big or small, and we have considered the various components of map. Okay, next we have tried to map the location on the earth using the grid of latitude and longitude. We have discussed about what is latitude and what is longitude. Okay, we have talked about prime meridian. Now this is one of the textbook questions, Delhi and Bengaluru. So here we have Delhi over here, right here, and Bangalore over here, right. Now approximately the same longitudes, 77 degree east. So this is the longitude, they each of them follow. Now how much is the time difference in local time between the two cities? The question is, why will there be a time difference? We are talk about time difference when we talk about different longitudes, right? Because we know that if there is a gap of 15 degree, then this means adding 1 hour or so. But here, so adding 1 hour. But here they both fall on the same longitude. So there should be no time difference between them. Okay? Okay, now let us consider these following question answers. First is, the parallel of latitude have the same length. What do you think? See here, I have already discussed the parallels of latitude. Say for example, this parallel over here and this over here. See, do you think they have the same length? This one is this much big, whereas this one is, see, so much bigger. Of course this is false. The parallels of latitude, they all have unequal lengths, and the length decreases as we move from the equator towards the poles. Okay, so this is false. Next is, the length of meridian of longitude is half of that of equator. Now if our earth is a perfect sphere, then this length and this length, the entire, they will be equal. But we have, remember in the very beginning we told you that the earth's shape is like this, that it is somewhat dipped over here and bulged out in this part. So what I am saying is, the shape is not very spherical, but it is somewhat dipped on this side and somewhat protruding on this side. So this means that the length over here will be more compared to the length over here. So this means the length of the meridian of longitude, that means here the entire length will be smaller compared to the length at the equator, since it is bulged out near the equator. Now next, the South Pole has a latitude of 90 degrees south. Here, yes, so North Pole is 90 degree north and South Pole is 90 degrees south. Okay, so of course this is true and this one is false. Next, in Assam the local time and IST are the identical. No, of course false. We already talked about the fact that local time at different longitudes are different, and so we consider Indian Standard Time IST for the whole of India. So of course the local time will be different because Assam is at a different longitude compared to your IST's longitude of 82.5 degree. Next, the lines separating the time zones are identical with the meridians of longitude. Correct? Right? You see over here, yeah, the various time zone separation. Time zone separation, they correspond to the various longitudes. We have covered a lot of things, students, so please study properly because most of them are important if you are preparing for Olympiad exams as well. Most of these concepts you will find in questions. So if you understand, if you try to learn and understand carefully, you will not have any trouble. I have shown various types of examples, drawings, diagrams. Try to understand them. If you have trouble, ask me in the comment box. Okay. And the last question is, the equator is also a parallel of latitude. Of course, it's a parallel of latitude at corresponding to 0 degree, right? Yes. It is the biggest parallel at 0 degree. So this is true and identical. This one is also true. Okay. Best of luck in your studying.